So that means that processes that move these ions to where they are supposed to be, or that move water to where it is supposed to be, are very important. And these processes can be categorized into active or passive transport mechanisms. One does not require energy, that is passive. So that means that it occurs along the electrochemical gradient. So you don't need energy there. No ATP is utilized. Or you actually need ATP in the form ATP to provide you the energy to move solids against the concentration gradient. This is the keyword here. So this is what happens with the sodium-potassium pair. So you have potassium and the sodium ion being moved across the cell membrane through what you call the sodium-potassium pump, and this utilizes ATP in the form, uses ATP as the energy carriers. So we say it is an active process. Still, this is a point that I'm emphasizing, that water moves from an area of low solid concentration to an area of high solid concentration, and that process is what we call osmosis. However, it's very important to note that we have specialized molecules that or channels that we can term as the aquaporids. These ones allow the movement of water through them. They are basically pores through which water can move following the osmotic gradient, and therefore this is not actually an active process. So that brings us back to the discussion of the role of the kidneys in osmoregulation. That is the role of the kidneys in maintaining water balance and also salt balance. If we are to recap what we discussed, we said that in the nephron, which is the functional unit of the kidney, you have a network of capillaries that form what we call the glomerulus. This receive blood through the afferent arteriole, which has a larger diameter compared to the efferent. Okay, the afferent diameter is larger than the efferent diameter, and because of this, the components the blood that comes in will have pressure, hydrostatic pressure, because of that difference in diameter. And because of this, you will have things getting out of these blood vessels, that is the capillaries, through the pores, those capillaries, and then form what we call the glomerular filtrate. So the high pressure pushes some of the glucose, amino acid, vitamins, salts, urea, and water through those holes to form the glomerular filtrate. So that means that the glomerular filtrate actually contains some of the things that we actually need. And some of the things that we actually need for osmoregulations are the ones that are actually in this glomerular filtrate. So they need to be reabsorbed such that that they have the maintenance of the water level and mean. So this is basically what happens. In the proximal convoluted tubule, you have the absorption of the most important molecule, glucose, amino acid, vitamins, and also ions to some extent. And then the lobe of Henry basically focuses on water, reabsorption of water, and also ions. And in this case, we are talking about actively pumping sodium chloride, and something that it does not go with the filter to form the urine. Okay, and then in the distal convoluted tubule, the discussion is about water. Reabsorption of water happens there, and the distal convoluted tubule actually can be influenced. Its function or its permeability can be influenced by a hormone, ADH, antidiuretic hormone, and this can cause it to be more permeable to water, such that water you reabsorb, such that you have concentrated urine being produced, and therefore can stagnate the water. And then now what goes into the collecting duct is now starting to be like what we would expect in the urine when it is actually passed out. But still you'll have more water reabsorption happening there. And then eventually when the urine that is to be passed out, that urine only contain the excess, and the excess of what is basically not required, because the other things have been reabsorbed by active transport, but also you have water also moving by osmosis. So the proximal convoluted tubule is able to get what is required by the body through what you call selective reabsorption, because it has features. One, it has a highly folded lining, and this increases the surface area for absorption. And it has a thin epithelium. That means that the distance for movement or for diffusion of these ions and nutrients is actually very short. The microvilli, which are the extensions, also increase surface area, numerous mitochondria to produce the energy needed. The proximal convoluted tubule, and then the loop of Henle, these are actually surrounded by a network of blood vessels or capillaries that actually take up what has been reabsorbed. Okay, we also hinted on the fact that some of the nephron components or parts are responsive to hormones, and we already talked about the antidiuretic hormone ADH, and then now we are introducing in another hormone called aldosterone. So let's look at how these two hormones contribute to retaining of water and mineral salts. So antidiuretic hormone. This hormone is only released when you don't have sufficient water in your body. So your body has what you call osmotic receptors. These are receptors that can detect changes in blood osmolarity, basically the amount of water in your blood, and this is in relation to the solute concentration. If you have no water, then it means that the solute concentration is actually low. But if you have less water, then the solute concentration is actually high. So osmoreceptors are able to detect changes in solute concentration or changes in the amount of water in your blood. Now, when you have little water, we're basically saying you are dehydrated. That means that your blood osmolarity is actually high. Okay, your blood osmolarity is actually high. And as a result, you have these osmoreceptors sending impulses to the hypothalamus to trigger the osmoreceptors are the ones that are actually in the hypothalamus. And then when they send the impulses to the anterior pituitary gland. The osmoreceptors in the hypothalamus will send messages or signals to the anterior pituitary gland to produce ADH, and then this ADH will have an impact on the distal convoluted tubule and also on the collecting duct to make sure that water is actually reabsorbed, such that the urine that comes out is actually more concentrated. And then the second hormone that is also very important to talk about is aldosterone. This one is produced in response to changes in sodium ion concentration. And its secretion is as a result of the adrenocortical trophic hormone being released from the anterior pituitary gland. that stimulate the adrenal cortex to release aldosterone. So the aldosterone will increase the uptake of sodium in the gut, that is the absorption of sodium in the gut, and also its reabsorption in the kidneys. And this usually is accompanied by elimination of potassium ions. The overall aim of aldosterone is basically to increase